Whenever people have acidity, they take a medicine which is commonly referred to as antacid, which is basically a base, and suddenly they get relief. Now, when you get stung by a bee, people will suggest you to apply toothpaste to it, which is also a base, and then you suddenly get relief. So see, something common is happening here. See, when you have acidity, there is excess of acid being built up in your stomach. And when you take an antacid or a base, the acid and the base, they cancel each other's effect out, and that's why you get relief. And similarly, when a bee stings you, a bee sting has some acid. It injects an acid into your body, which hurts, which burns. And when you apply toothpaste or baking soda, these both of things have a base in them. And the base and the acid, they cancel each other's effect out. And that's why you get relief over here. So we can see that a common pattern is that acid and base, they cancel each other's effect out. Now let's see how this happens. So for this, I'm going to take an example. I have an acid, HCl, and I'm going to react this with a base, NaOH. Now see, when I mix HCl in water, this is going to dissociate into its ions. I will get H plus ion and chlorine minus ion. Similarly, when I mix NaOH in water, this will also dissociate into its ions. I will get Na plus ion and OH minus ion. Now see, when I mix these two together, there will be double displacement reaction happening over here. Ions will exchange position. So let's see what we get here. Here, sodium will now get attracted to chlorine minus ion. And finally, we'll get NaCl, which is a salt, by the way, the common salt that we eat. And similarly, H plus ion will now get attracted to OH minus ion. And finally, we will get water, H2O. Okay, so here acid and a base, they both are reacting to give us a salt and water. And you know, the fun thing is that both of these are neutral in nature, meaning they are neither acidic nor basic. Now you might be wondering, Ram, how am I sure that NaCl is not acidic or basic? See, I know about water, that water is neutral, but how am I sure about NaCl? So see, we define acids as compounds that increase the amount of H plus in an aqueous solution. So here when we mix HCl in water, it gives out more H plus. Therefore, it increases the amount of H plus. Similarly, we define bases as compounds that increase the amount of OH minus when mixed in aqueous solution. So when we mix NaOH in water, it gives out more OH minus, and therefore it increases the amount of OH minus. Whereas when you mix NaCl in water, it will neither increase the amount of H plus nor will it increase the amount of OH minus. And that's why NaCl is going to be neutral. So we can see that acid and a base, when they react, they cancel out each other's effect and they form neutral compounds, a salt and a water. Okay, now just to be sure, let's look at one more example. So this time I have again HCl acid, which in water will dissociate to give me H plus and chlorine minus ion. And this time I'm going to take another base, calcium hydroxide, CaOH whole twice. And in water, this is going to dissociate to give me calcium ion, Ca plus 2, and OH minus 1 ion. Okay? And since it is giving me OH ion, then I can be sure that this is a base. Now, if I react them, again, double displacement reaction is going to happen. The ions are going to exchange position. So calcium ion will now get attracted to chlorine minus, and we will get calcium chloride, CaCl2. And H plus will get attracted to OH minus ion, and we'll get water, H2O. Let me quickly balance this equation. So here I see 2 chlorine on the product side. So here I will write 2. Now I have 2 hydrogen, 2 more hydrogen, meaning 4 hydrogen. So here I will write 2. So I get 4 hydrogen, 2 oxygen, 2 oxygen, and 1 calcium. Okay, this is now a balanced chemical reaction. So here also I see that an acid reacts with a base to give me salt and water, both of which are neutral, meaning the acid and the base, they are cancelling out each other's effect to give us neutral products. And yes, this is a salt. Calcium chloride is a salt. See, salts are basically compounds that are made up of ions. Here calcium chloride is made up of calcium plus 2 and chlorine minus 1 ion. Here sodium chloride is made up of sodium plus 1 and chlorine minus 1 ion. And salts can be formed when acids and bases react with each other. Okay, so the conclusion is that an acid reacts with a base to give us salt and water, both of which are neutral products. Okay, so technically speaking, acid and base, they are cancelling out each other's effect and giving us neutral products. And that's why we call this type of reaction as neutralization reaction. By the way, later you will study that some salts can also be acidic or basic. They need not be neutral. But don't worry about this right now. Okay, with this I have a question for you. You have been given that a compound X reacts with NaOH to give us a salt and water. Can you comment anything about X? Pause the video and try this by yourself first. Now if you have tried it, let's see. See, here we are given that NaOH is one of the reactants, and we know that NaOH is a base and it is giving us salt and water. Then I know for sure that this something can only be an acid. It could be any acid, I don't know what acid it is, but it has to be an acid. Okay, with this another problem. Similarly, if we say that H2SO4 is reacting with some Y compound and it is giving us salt and water. So I can be sure that since H2SO4 is an acid, it can only react with a base to give me salt and water, okay? So this can be used to define acids and bases. Something that reacts with an acid to give salt and water is a base, and something that reacts with a base to give salt and water is an acid. Okay, now with this, let's look at an experiment of the same thing. So here I have taken a base, NaOH, into this container. And the reason it looks pink because I have added phenolphthalein indicator to it. See, we have seen in an earlier video that when we add phenolphthalein indicator to a base, the color changes to pink. And when we add phenolphthalein indicator to an acid or a neutral solution, the color remains colorless. Okay? So here in this container, I'm going to add HCl acid drop by drop. And you can imagine what's going to happen. Each drop of HCl will neutralize a drop of NaOH. But see, we had taken a lot of NaOH to begin with, right? So that's why it will take some time for all the NaOH to neutralize and vanish. Let's mix more HCl. And yes, the color vanished. Now it's no longer pink. So at this point I can say that there is no more base present in the solution. The acid and the base, they are in equal quantity and they have neutralized each other, and we have neutral products in this container. So hopefully this satisfies you that an acid and a base, they neutralize each other. Now let's summarize the video. In this video we saw when an acid and a base react, what are the products that get formed? And in general, what do we call these kind of reactions?